Hello everyone, this is Jyoti. Welcome back to my channel. In today's video, we will be talking about automation and programmability. So let's get started. In this video, we will be talking about how automation benefits network management. We will compare traditional networks with controller-based networking. We'll talk about controller-based and software-defined architectures. We'll also talk about what is REST API and configuration management mechanisms. So the first topic is network automation. Network automation is a methodology in which software automatically configures, provisions, manages, and tests network devices. It is used by the enterprises and ISPs, internet service providers, to improve efficiency and reduce human errors. There are two types of network automation, that is software-based network automation and script-driven network automation. The benefits of network automation are improved efficiency, reduced likelihood of human errors, and lower operational cost. The traditional networking versus controller-based networking is, in traditional network, it comprises of several devices, that is routers, switches, firewalls, etc., that are equipped with software and network functionality. There are two planes, data plane and control plane. The data plane, also called forwarding plane, is responsible for the forwarding of frames or packets, whereas the control plane is responsible for controlling the forwarding tables that the data plane uses. So in the traditional networking, the traditional architecture was based on two planes, data plane and control plane. Whereas if we talk about the SDN architecture, it is slightly different from the architecture of traditional network, as it comprises of three stacked layers. The three stacked layers are data or forwarding plane, control plane, and application plane. So the SDN architecture is segregated into three different planes: for hardware, for applications, and the controller, which is the brain of the architecture. Here you can see that there is a control plane and data plane in the traditional architecture, whereas in the SDN architecture, there is application plane, control plane, and data plane. This is basically the difference between traditional network architecture and SDN architecture. In the SDN architecture, between these separate layers, the APIs are the interfaces that works between these planes. So between application layer and the control plane, there is the API that works, and we will talk about it, what type of APIs are these. Then between control plane and data plane, there is another API that works, which is called data plane. As the SDN controllers use APIs to communicate with the application and the data plane, there are two types of APIs. So the two types of APIs are northbound APIs and southbound APIs. Northbound APIs currently are still in development phase, where very little has been done for unification. Different applications use different APIs. So there are still many northbound APIs that we are working on, and they're under development. Whereas southbound APIs are a few, like OpenFlow, NetConf, and OpFlex. OpenFlow is used to configure the flow tables in switches, NetConf to configure devices with XML transactions. So these are some APIs that works between the planes in SDN architecture. So here you can see that there is SDN applications, controllers, and network elements. So these are the three different planes or layers in the SDN architecture, and between these layers or planes, there are APIs that are working. So between SDN applications and controllers, the API that work is called northbound API. Northbound API is used for the communication between SDN applications and controller. Similarly, between the controller and network elements, that is the infrastructure, the API that works is called southbound API, which is used for communication between these two layers, controllers and network elements. Now let's talk about what is REST API. REST API, where REST stands for Representational State Transfer, it is a set of rules that developers follow when they create their API. One of these rules states that you should be able to get a piece of data called resource when you link to a specific URL. Now here, each URL is called a request, while the data sent back to you as a response is called response in the terms. So these are the two terms that we need to know in REST API. There is a request and response. Each URL is a request and the data that is sent back is called the response. So the anatomy of a request is there is the endpoint, the method, the headers, and the actual data that is contained in a request. The configuration management mechanism. Now, configuration management is a process of tracking and controlling the changes in a software with respect to its requirement, design, function, and development of a product. This is configuration management mechanism. There are two types of configuration management approaches. One is pull model, the other is push model. In the pull model, the nodes are dynamically updated with the configuration that are present in the server. So what happens, the nodes dynamically pulls the configuration that is updated on the server. Whereas in push model, a centralized server pushes the configuration on the nodes. There are three different types of models: Puppet, Chef, and Ansible. These are three different tools that represent different paths to achieve a common goal of managing a large-scale server infrastructure efficiently with minimal input from the developers and system administrators. All three configuration management tools are designed to reduce the complexity of configuring distributed infrastructure, resources, enabling speed, and ensuring reliability and compliance. Here you can see the Puppet model. In the Puppet model, there is a repository where we save the configuration that is called config repository. There are some Puppet agents. These are the nodes, and Puppet master, which is the brain of this model, from where the configuration is pushed to the Puppet agents. In the Chef model, you can see there is a Chef workstation, there is a Chef server, and Chef nodes. These are the components of a Chef model. Then lastly, there is the Ansible model. In the Ansible model, there is the Ansible Python API, which is used. And there are the infrastructure like the switches, routers, and remote servers, etc. In the Ansible model, there are some components called playbooks, Ansible configuration, and core modules. There is hot inventory, command center, and custom modules. So to know the depth of these models, that comes under the advanced automation and programmability. But for the scope of CCNA, you have to know the overview of these models as well as what is programmability, what is SDN architecture, and the three-layer architecture in SDN compared with the traditional architecture. So in this video, we have talked about the overview of automation and programmability. I hope you liked the video. Thank you very much.